Hello, in this video I'm gonna tell you about the neural network and kmeans algorithm. This kmeans algorithm is implemented in Python and this neural network is implemented in C++. I still know how to implement this neural network in Python, but still I want to know what is the efficiency of the code. Surprisingly, there's a very big variation. And now let me start with this kmeans, then I'll go to the other code. In this kmeans algorithm, I didn't use any libraries except some basic like math and random. In here I'm defining the number of points I would like to add here, and this is the dimension. This determines the space in which the point acts. If I put 3, it's a 3-dimensional space, and this is the lower bound and the upper bound values, and it's a k value, maybe 3, 4. It determines the number of centroids I have, and cutoff value, this value determines when to stop the iterations and form a final cluster, and these points will generate the random points and store it in an array so that I can use it for the code. Instead, I can replace this function with some set of 20 points for this code, or if I would like to manually input 10 points, then I can change this value here to 10 and put some 10 points with xy coordinates. Okay, so if this is a 3-dimensional space, I need to put xyz value. And now I have a cluster here, which is equal to the kmeans function, which takes 3 arguments, points, k, and cutoff. This kmeans function is taken to the other place where I have defined the whole function. So this is the kmean function. It has a loop counter here, which keeps track of the number of points it's acting on, and it also calculates the distance between the points from the centroid, and then it appends those points with the cluster index. So that's how it manages the cluster. And then coming after, I have a loop here. This loop actually prints the cluster number and its associated points. Then I have class point, class cluster, and all these associated functions. Okay, get distance. Okay, this is the function for making a random point. This will tell me how many iterations it went through to make this final output. Let me run this code. Now first debug this code so that any of the changes made here will get reflected. Okay, it's working fine. I can see the output all the way at the bottom. So totally it went through 4 iterations, and this is the cluster number for cluster number 1. So getting back to the code, in here I have 20 points. So this 20 points is split among cluster number 1, 2, and 3 because I have k is equal to 3 here. If I want to put k is equal to 4, then it's going to divide into 4 clusters. See, 1, 2, and 3, and 4. Okay, and then keeping back 3, and if I have 10 points in a 2-dimensional space, I have 10 points split among 1 and 2 and 3. So this cluster is basically calculated using the distance between the points and the centroid. So instead of making a random points, I can put some point here and calculate whatever I need. So this is about the k-means. And now moving over to neural network. In here, this is a basic C++ program. This doesn't use any kind of libraries. Everything is implemented very basic. So this is how it works. It needs IO stream for input output streams. It needs a vector because we are calculating with the vectors. Of course, it needs a math function to calculate the square root and all the stuffs. So x, w, and y, input, weight, and output. So what I'm actually doing is, this is some set of input with some set of weights with some set of outputs. For these set of inputs with these set of weights, I need to get these set of outputs. So this is what my training data says. And now I am applying sigmoid here. And also if I want to use linear or any other activation function, I can replace the sigmoid with those functions. Okay, you can change the weights here. Like I just want to put 0.4 in all the cases so that it's easy for them this code to get work on. Okay, for the set of values, for the set of weights, the output should be 0 0 and 1 1. Coming after, so here's a sigmoid function. So this is the output of the sigmoid function. For making this functions work, I actually need a math function, so that's why. And now I'm going through an operator overloading here, which makes the process more easier. And again, operator overloading here, and a transpose. So this is something like a matrix multiplication. Basic matrix multiplication really actually works with a neural network. Okay, so in here I have some predicted values. These predicted values are then put back into the sigmoid function, and then calculate the errors, and using those errors the final output are determined in that way. So let me run this code. So let me go back to this kmeans and run it again and see the time it takes to run. So it hardly take half a second. When I come back to C++, calculate the time it takes right from my debug here. It's more than 4 seconds actually. So this is the output I've got. So 0.04, 0.00, 0.95, 0.97. Going back to the top of the code, in here I have 0011 with these set of inputs, with these set of weights, and these are the outputs I've got. Instead of 0, I've got 0.04. Instead of 0, I've got, I think it's kind of perfect here. In here, instead of 1, I've got 0.95. Here, I've got 0.97. So this is a basic neural network that has been implemented. Thanks for watching.